here's what you need to do, or what I think you need to do, when you're encrypting one object. So you've got first a ProUtil ePolicy manage encrypt command, so that creates the policy, doesn't encrypt any existing data. Then you've got ePolicy manage update, which does update all the data. So what it does really is it begins a process for scanning all the blocks in that object. So you can just trust that it's eventually going to finish, but that's, to me, kind of like starting a backup and trusting that it will finish. What you really want to do when you're doing a backup is check that you saw the command that said backup completed successfully. So the equivalent here is you're going to do an ePolicy scan at a later time and prove to yourself that you got this message that says X of X blocks encrypted. That's when you know, at least from a compliance perspective, that you're actually done. So it doesn't actually do anything. It's read-only. It doesn't do anything, to the blocks. But that's just how you prove to yourself that the update did actually do what you expected it to do. So if you've got 3 commands for one object and you've got, let's say, 1,000 objects you want to encrypt, you're not typing 3,000 commands at the command line. So even if you have, say, 20 or 50, it quickly becomes unwieldy and you're going to want to automate. So even if you are not considering doing full database encryption, these techniques that I'm going to talk about, they're still going to be applicable for you because you're going to have a similar sort of workflow. So I'm going to show a very sort of simple hello world type of workflow. So I've got a set of programs that create shell scripts, and those would be shell scripts that you would run, and those are going to produce outputs that you can then scan. I'll just note here that there are a couple of canned reports in the data dictionary for TDE. I consider them basically useless. Sorry, that's harsh, but it's true. Those reports, one of them is a detailed list. It gives you current and previous policies for each object. And the other one just gives you current policies. They both only tell you about objects that you've encrypted at the object level. It doesn't say anything about areas, type 1 areas that you've encrypted. And it also, importantly, doesn't tell you about the objects that you haven't encrypted. So if you want to encrypt everything, or if you have some curated list of objects that you're maintaining that you want to make sure they are encrypted, using those reports, you would have to carefully scan to see, is every one of the objects that I care about in that list? It's not going to give you a comprehensive list that you can just grab and look to see, am I where I need to be? So let's switch over to VS Code and take a look at that. Okay, so referring back to our list, I've got a program called list objects, and what I've done in that program, I'm not going to go through all the code, that's not terribly interesting, but I'll just describe what it does. List objects is going to make a list of all of the encryptable objects, that is all of the type 2 objects and all of the type 1 areas. And it's going to produce 2 text files. So it's going to produce a list of encryptable objects, which is, again, those objects that I mentioned, and also unencryptable objects, which are basically any tables, indexes, or logs that are in your schema area. So it's going to tell you that you've got some remediation to do if you care about encrypting this data. That encryptable objects text file then will become input for some of the later programs. So there's one called create policies, and it's going to create a shell script that will emit ProUtil policy encrypt commands. We'll see that in a moment. Then you'll run that to generate the policies. And then next up, we've got a view policies program, which is going to emit ProUtil policy view commands in a shell script. You'll run that to get a list of objects and all of your objects and their policies, if any. And then in the last program, parse policies, That'll take as input the policy list and a cipher that you specify, and then compare your target cipher with the ciphers on each of those objects and tell you a little bit about their compliance status. This is not intended to be, production grade code. It's basically sort of a hello world example to demonstrate for you what the workflow is for building your compliance process. Okay, hopefully you can read that. The text is a little small, but so first of all, the list of encryptable objects. This is literally just object type followed by object name. Okay, so this is very simple. It's just, in this case, I'm running it on a sports database, and it's a slightly modified sports database, so I've got a little bit of variation in it. And in this case, I've got a couple of type 1 areas. I've got some tables, some indexes, some logs, and these are all the ones that can be encrypted. And then there's also a report. I call this unencryptable objects, and it's a list of all of the objects that are in the schema area. So you would run this against your database and see, do I have some cleanup to do and get those objects out of the area so that they can be a target of a policy. After running the program that creates a shell script, in this case, you're seeing it as a batch file, but the concept is the same. It's literally, the program is just going to produce this list of pro-util commands that we saw earlier. These are pro-util, ePolicy, manage, encrypt commands. And what the program did was it consumed this text file, the encryptable objects, and produced this shell script, so that you're not doing all this manual typing. And again, if you had your database configured in a more secure manner, like with either a manual start on the key store or auto start user, then you would have to specify the passphrase when running these, because they are privileged commands. So once you create the policies, then there's the program that creates this shell script to view all the policies, and they all just get emitted into one file called policy list, and it looks like this jumble of stuff, which you don't want to be reading if you have thousands of objects. So I have a parser that turns it into something a little more appetizing. So this gives you the list of objects. You also pass in your target cipher. And so basically it's going to compare what is the current status of the object in terms of its policy or policies, and compared with the policy that you specified you want it to be on. So in this case, I ran it with AES 128. I said, that's my target policy. I want everything to be encrypted under that. And you can see the status. This is just me comparing your target to what it should be. So in the case of the second line item, it's encrypted with AES 128. There was no previous policy, so that's compliant from a policy perspective. Whereas, let's say this one at the bottom, it has a previous policy, which was DES. So the comment there is ePolicy update required, meaning that object could have some blocks that were encrypted under the current policy, so you're not technically compliant. And some others that just don't match, it says wrong cipher. This one here, I'll note, because that object is no longer encrypted. If you have an object that's encrypted, you can, to decrypt that one object, what you do is you issue another pro-util ePolicy cipher command to change the policy to null. So that means from that point onward, any block writes won't be encrypted, but you could still have other blocks that are encrypted under the previous policy. So that's as much of the workflow as exists right now. I have code for this, and I'll give you my email address at the end if you want to look at this sample code.